Welcome back. Okay, back into our interpreter. Second episode of Barely a Lang. We're continuing our interpreter that we started in the last episode. A very simple interpreter for a very simple language, hence the name Barely a Lang, because it's so simple. We've got this initial example of the language, which I shamelessly stole. Why do I have? Oh, let's get rid of that window. Which I shamelessly stole from this repo. I watched his video first. I can't really remember it very well. Uh, he went through the code, but I don't really remember how it went, so I've just been writing it from scratch myself, more or less. I'm sure I'm remembering some little bits and using them without really thinking about it. But we implemented enough to get this first example going. Since the last episode, I did manage to tidy up a couple of things. I committed it to source control. I noticed that when I open it now, it has a nicer, we have nicer colors. Syntax highlighting, that's the fancy term. We have nicer syntax highlighting. There are a couple of issues with the code. It's very simplistic so far, because this is just a linear process, basically. It's linear, and then when we get to this jump, we might skip a couple, but then we continue later. So what this allows us to do in our interpreter is simply just go through the file, run all of the instructions, and when we get to this jump, all we're doing is then skipping any instructions until we find the label, and then we continue as normal. So I think we'll find out pretty soon where that will not work, but that's what we've done so far. Another thing that I noticed was we've got this error handling here, which is not quite right. I should have done that. I'm guessing success is a bool. Oh, ID error. Am I going to get... I'm not sure if I'm going to get the info that I want. Success bool. So we're using Odin. So far it's been nice, but I've been fumbling a bit since the last episode was my first time using it. But enough of that, let's get stuck into it. Since we finished this example, let's go back to the repo and open program 2. And let's try to remember what this program actually does. We can see at the bottom immediately that it's printing even or odd. So I am guessing the idea is interesting. Push a number, push another number, add them together. If the answer is equal to 0, then we say it's odd. Okay. And then we have this loop. We push 2, we subtract 2 from whatever result we had. And if the jump is equal to 0, then we say odd. If the result is greater than 0, we go back to the top of the loop. And I guess if neither of those are true, then we print even and halt. So it seems like I'm a little surprised by this. We can do this in the beginning, but I think the idea is to have two reads, like we did in this program, so that the user can input two numbers. This just seems to have two numbers hard-coded. I'm a little bit confused by this top part, to be honest. Push 232, push 1, add, so that should add them together. You get 233. Jump if equal to 0. I was reading that as jump if even, but it's jump if equal to 0. So if you add them together and you get 0, we're not supporting unsigned. We're not supporting signed numbers. We'll have to adjust our code a little bit for that, because we shouldn't. I think we should not support signed numbers, only unsigned integers, because it just makes things a bit simpler. Okay, so we add the numbers together. I think really this could just be a read. Just read a number and then tell me if it's even or odd. But whatever, we'll start with these. So we have a lot of these already. I think we have jump if equal to 0. Yes, so we need jump if greater than 0. That should be easy. We need to be able to push a number and add. Although, once we change this just to a read, I think the add will not really matter, but let's implement it anyway. Why not? The biggest hurdle I think we're going to have here is this loop, because we have jump greater than 0 loop, and that's telling us to go back up. Like I was saying before, our current interpreter just goes linearly down through the commands. So it would come to here and it would say, okay, I need to jump to loop, and then it would just skip everything until it gets to loop, and it's never going to get to loop. So we're going to need to do something about that. Let's take this code and put it in our examples. New file, test02.ble, like so. New line at the end, just because. All right. Now, first things first, we are hard coding which file we grab. Do we want to do something about that? os.args. It's a string array. Okay, now I'm curious. I'm already curious. Let's just try this and see what happens. In C or C++, you'd get the arguments here, but the first argument would be the name of the program. I managed to get this working now, so we'll just press play here. So this is it, yeah. So, yeah, it's the qualified name of the program. Okay, so let's stop. Let's go 1. Now, I'm pretty sure that arrays in Odin, argv arguments converted to Odin strings, are bounds checked. So if we try to run this, yeah, illegal instruction out of range. Great. So I think what we need to do, I keep doing that, is say if args, oh, I think we have to use the len function. I need to get better at doing this kind of thing. If there's if it equals 1, because that would be the program name, that's not enough. We want more. So we can say like a usage barely AI file, something like that, and then exit with 1. Now if I run, just prints usage. Because you done fucked up. You don't have the right arguments. And now I think we can just go like this. Just put the first argument there. So then up here, program arguments, I should be able to go examples barely. Oh, that's what I did last time. Chest_01.barely. Apply that and run. And it works. And picked up the file and interpreted it. Great. This is our first job of the day. Small win. I do like that in programming. Get just a little something going. It's a nice way to start. So now this is going to stay the same. So I might just edit my configuration and actually say barely AI test 01. And then there must be a duplicate, copy configuration. 02, apply, run. Runtime assertion. Okay, interesting. We don't really handle this. So if you do this kind of thing wrong, so to back up a bit, it's here. This line is where we have the issue. And I think what's happening is we're getting to here. I guess these commands are getting ignored because my interpreter doesn't know what they are. And if it doesn't know what it's looking at, it's just going to go through all of these if-elses and then come back to the next line. So it's just ignored these ones, and then it's got to this one. And it's saying jump if equal to 0. Now our language is stack-based. So implicitly it's saying jump if whatever's on the top of the stack is 0. Now, we don't have anything on the stack. So when we go to pop, we get the 0. So we could have better error handling. We could say empty stack. Nothing on the stack. Should we bother doing that? Okay, let's do it. If len stack equals 0, then we want to say stack empty. Stack empty at line blah blah. Like so. We could do that to our other ones. So print does not need anything to be on the stack. subtract needs two things on the stack. So we can say if it's less than 2, let's say less than 1. Somehow I feel like that's a little more intuitive, because if the length is less than 1, then something's wrong, which kind of correlates to the fact that we need one thing. And over here we need two things. So if we have less than two things, stack too short. Maybe I'll just make this a generic, stack too short error. Reads from the command line and appends, so that's all good, and jump. So that's it. Those are the only commands we've got so far that are an issue. So now if we try to run this again, we get stack too short at line 4. Line 4, the stack is too short. Okay, great. Now, I think we should implement this push. Do we want to have some sort of reasonable ordering to these things? What's that cat up to? Just a moment. Okay, cat taken care of. Yeah, I wanted to kind of group these operations a bit. And I already cut it, didn't I? So I thought we could put, read and print together. These are the console ones. Halt makes sense to go at the end. Actually, let's even go to here and say invalid command. Are we calling them commands? Yeah, why not? At line. So now we should get something more like invalid command at line 1. That's nice. So here we have a jump, our sub. So let's add a push. This should be real easy. Real easy. So when we read, we get the number, and then so we're probably going to need to do something similar to this. A push. We're not reading it from here. Instead, so let's take that away. I think we just want to slice the line, don't we? Slice the line at the space index. And can I do U64? Yeah. We talked about this before, didn't we? We only want to support unsigned integers. So let's go U64. So we just take the, yeah. Oh, no. We don't want that. We want space index plus 1 till the end. That's what we want. Let's see. I think this could be a problem. Like if I go like that and then run, wow. U64, I64. Yeah, needed to change that one. So that was a compile error actually. Invalid int. Okay. So that's not so bad. So now let's see if we can debug this. No debugger is configured. Bundled. Usage. Getting the usage printed. So it would seem that something is wrong. I won't spend too much time on this, but I'm just curious to see what happens if I print out the args. So here, yeah, we have the program name and then the input file. And if I do this, we're not getting the input file. Well, that's weird. Okay, let's not try debugging then. Instead, whoops, let's just do something like pushed if so it's %u. No, I don't need to change those to %u. And let's try running that. I guess it's not %u, so just %i. Okay, yeah, looks good. Pushed, and then invalid command. So we have our push. Now add is going to be really easy because it's the same as subtract, but we do plus instead. So then we go like that. Okay. Oh, we're still printing this. We don't want to print that. Run that. Invalid command at line 6. Because it's a label, and we only handle labels if we go in here. So only if we have a label to jump to do we handle labels. Okay, so this is where things get a bit more complicated. I think we're going to have to split our little interpreter into 2 loops. The first loop is going to be a really basic tokenizer. And yeah, the first loop will be a very basic tokenizer. The second loop will then go through the tokens. Okay, and interpret them. So the second part will be the actual interpreter. The first part will be the tokenizer. So, as well as lines, let's say we want some tokens. Yeah, let's just make an array of tokens. So we'll just do a dynamic string array. Oh, is that not allowed? Cannot be inferred. Yeah. Because this is an assignment. This is just a declaration. Declaration assignment, declaration. Okay. So we have our lines from the file. We have our tokens. Let's try to group these together in a way that kind of makes sense. And then we loop through. Do we even care about lines? Let's call this. Sorry, I'm going on a tangent here. Let's call it input file. And input data can be, whoops, can be this. Oh my God, I'm making a mess. File open error. File read success. That's how we get our input data. And then our source is the input data. I'm going to get rid of that lines because I don't think we need it. So we're going to loop through the source. Char in source. Yeah, it's type char, makes sense. Are we going to record where we were? So for error messages, up until now, we've got this, invalid command at line 6, which is nice. So these tokens, okay, I was thinking that we wouldn't bother with this, but we don't want to take a step backwards. We already have these nice error messages. So let's continue. I don't know if it matters where I declare this. Let's say token is a struct, and inside that struct we have a value, string. We have a inline number, which is just a regular unsigned number, and we also have a column number. And it doesn't like that. Do I need it in equals, or what's going on here? Unexpected bracket. I thought this is how you declared a struct. Let's have a look-see. Destructor, no. Constructs, like a struct literal. Struct, there you go. Foo : struct, curly bracket. I wonder if it's because I tried to declare it inside a function. Is that not allowed? No, that seems fine. Is there a convention where I have to? Surely not. No. Foo : struct, open curly brace. Oh, they're comma separated. That's what it was. Comma separated. Let's leave it up there. So we actually want an array of tokens, dynamic array of tokens. And we want the token value, which is a string. So token value, can I just do token value plus equals char? Strings dot concat or append. Oh, I wonder if I can just do this. Will be interesting. Can I do that? No, that's for arrays. So strings dot append does not seem to exist. Concatenate does. So let's make the token value that. Cannot assign value token value of type string to bracket string and a procedure argument. So maybe this is, oh, wait a minute, that'd be an array of strings. Let's have a look at concatenate. So you pass in an array of strings, okay, and the result is a string. And you potentially get an allocator error. So how do I do an array literal? Is it like this? There we go. But char is actually a string. Maybe there's an easy way to do this. Okay. Token start. Token starts at 0. True if R is a white space character, false otherwise. So they have this term rune. So this is my rune. So I'm going to say if we come across white space, whatever was in the token start, from the token start up till now, is our token. So we're also going to need to check keep track of our line number and our column number. And if we come across something that's white space, we'll have to review this when we get to the double quotes. Then that's the end of our token, right? So that means that we go append to our tokens the struct literal which contains substring of source from token start to index, oops, and a couple other things. in here. Let's just fill this out and see whether that resolves all this stuff. The line number and the column number. So, no procedures or ambiguous call for procedure group append that matches with the given arguments. Invalid type. Do I need to say value equals, line number equals, column number equals? Okay. What's wrong with line number? I do find it a bit funny, like, where to put the spaces, you know, because these are all the same except this one has a type. I'm explicitly saying this 0 is a U32. Here I'm just saying it's any old number. And because of that, we put the spaces in different places, and that all feels a bit weird. Okay, so what is the issue still? That should be just an int. So can I just make these ints here? Is there a type that's just int? There is. Okay, I can just say int. All right. And can I just go like this then? I feel like I don't need to specify those. Okay. And if I were to just take that away? No, that needs to be there. Okay. So we loop through when we get to a token, somewhere where we say, okay, a token is finished. Then we say, okay, great. So if the character is a space, we fill in the previous token, and then we want to reset token start. Token start equals index plus 1. I'm not sure I'm liking this so much, but let's just keep going and see what happens. So token start equals index plus 1. So we're saying that the next character is it. And before we do this, because there might be multiple white space characters in a row, oh, sorry, we say if the token start is not this index, you know, if there was a previous, you know, the token did start before this, there is a token. So this is effectively saying if there's no token. So it makes sense then after we're done with that to set the token, we're saying we're starting the token in the next character. So then when we loop around, if it's white space again, then this will evaluate to false, because here we've said that that index is where the token starts. So we'll just skip this, and then again it will say the next character is where we start, and it will just keep doing that until we get to a non-white space character. That's the theory. No, format dot print line. So let's print our, can we just print our tokens? Does that work? And let's just comment out the rest of it. For now, what happens? So we have push, we have 232, we have push, we have 1, we have add, we have, sorry for the scrolling, it's probably not so nice. We have jump equal to 0, we have L1, we have loop colon, we have push, we have 2, we have sub, we have jump equal to 0, L1, jump greater than 0, loop, print, and our literal halt L1 colon, print, and our odd literal, and then halt. But if I do this, if I say oddy odd, let's do it up here because I know I'm in the way of this part. So if we run that, I scroll across and I find it. Where are we? Here we go. Yeah, this is the issue. Eveny, you know, it's got double quote eveny and then even double quote. But that should be one token. So we need another, we need to keep track again of quote open. It's false. And then we can say if char equals, I guess I have to escape it, this, then quote open is true. Oh, I don't need to escape it, do I? Actually, that means quote open is not quote open, that's toggling whether the quote is open. And not while the quote is open. When the quote is open, then we can't finish our token. Okay, we can't finish our token until the quote is closed. Let's do an else to make it more clear. Actually, I would like to try switch char case is that. Now, the reason I want to try switch in Odin is because, can I do this? Mismatched types, bool and rune. Okay, we won't do it right now. Maybe we'll do it for something else. But the reason that I wanted to try a switch out, and I would like to try a switch out in some case, at some point, is that it doesn't automatically fall through. So if we had here slash or something, I don't know, something like that, and char was a double quote, it would execute this, and it would skip this. It would not do that. And the default would be like this. You just have a case with no character. That's not, in other languages it would be default, but in Odin it is case. Another thing that's nice about them is if you were enumerating, if you were switching over an enum, or something that has a fixed set of values, it will enforce that you account for every case, which is really nice. There's something that a lot of people say for object-oriented. That's like one of the arguments for object-oriented code is if you just have switches everywhere instead of polymorphism, then the compiler doesn't tell you when you are missing something. But in Odin it does, so that argument goes away. Yeah, I'm not the biggest fan of OOP. So now we've done our quote thing, which was actually, I think, easier than I was expecting. And let's see what happens. Exit code 0 is always a good sign. Sub L1 greater than 0, print. Okay. 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 So I think the condition needs to be here. Because now I'm getting print, and then I'm getting the second token, you could say. Getting print. Let's stretch this out a bit. Getting print, and then I'm getting this, and that's getting skipped. And I think the reason was because we get to this quote. It says, okay, quote is open. And then we would get to this condition, and when it was like this, we get here. We would loop through all these characters. It doesn't do anything. Well, no, that's not true. It does do something because it enters this else if. No, it doesn't, because they're not spaces. Okay, so it does do nothing. When it gets here, it enters this. And even though we had it like this, so it would not go in here and declare it a token, but it would come here and say the token starts here. So then when we did eventually close and get to white space, now it creates our token, and because it's saying this is the start, it's going to give us this. So the solution is to move this out here. So that as long as the quote is open, we don't do any of this. We can't finish tokens, and we can't update where the start of the token is either. So let's try and run that. Fingers crossed. Where are we? Print. Even. Can you see that? Yeah. Even. That's exactly what I wanted. Okay. So let's put that back. But I just wanted to make sure we could handle that case, because when you've got quotes there, that's usually the idea, is that you want to make sure that you keep it all as one token. Well, in our simple case anyway, we'll just call it one token. Okay, so now we have a bunch of tokens, but the line numbers and the column numbers are totally wrong. So another thing we can do when we get to white space is we can say, Okay, interesting, interesting. I'm also going to do this. This might seem a bit strange, but it's the same kind of, well, it's not index plus one, is it? So if we're in white space, so actually what we want to do is we want to say if it's the new line character, then column number equals 0, line number plus plus. Oh, postfix plus plus is not supported. Interesting. Okay, equals line number plus 1. Oh, can I do plus equals 1? Yeah, okay. Interesting, they don't support postfix. I have heard that that's a bit of a complicated operator. And I mean, plus equals 1, I guess it's a bit more explicit and it's not really much more verbose, so why not? So when we get to a new line character, we increment the line number and we reset the column number. Maybe we can do that. So column number plus equals 1. Well, I mean, any character is going to mean that the column number is plus equal 1. But let's start them at 1. I guess reset the column number back to 1. Let's see what happens, huh? So push is at line number 1, column number 5. So actually, let's invert this and just say else. So now what we're doing is we're saying first check if we're finishing a token, and then do our token finishing logic. So that, yeah. This whole tracking of column and line is a bit more complicated than I thought it was going to be. Okay. So I think in here we're also going to have this. I guess we can combine these. So first is a white space. That's the first thing. If it is white space, then we update our token start. But you know what? This needs to be after. I feel like we've gone in circles a bit here, haven't we? I feel like we've gone in circles, and I feel like we're going to reintroduce a bug. Okay, so let's get this cleared up. So if we get to a space and the quote, we haven't got an open quote going, and we did start a token before this, then finish the token. Now, regardless of whether we were finishing a token or the quote is open, or who gives a shit. We want to put the token start to the next character. Line number, column number. You know what? I'm going to give up on this. I feel like I'm just going to fumble around too much, and it's going to add too much complication to this. So let's just not worry. Tokens are just strings. Very simple. Let's just verify that we got the right stuff. Looking good, looking good, looking good. This is broken again. Oh no. Evenly even. Even. I went and broke it, didn't I? Evenly even. Okay. Apologies for the detour, but we're back on track now. We have tokens. We have tokens. So, tokenize, tokenize, tokenize. Interpret. We'll uncomment that. So now we're going to loop through the tokens. But we're going to use a basic for loop. What is the basic? What is the basic for loop? For statement. Here we go. Okay, it really is the basic for loop. Looks pretty familiar. I like to have full names, not just letters. While it's less than the length of tokens, and then token can be tokens index. Okay. So this kind of stuff was about tokenization. This was the label jumping. We'll figure that out a bit later. So I wonder if we can switch on our token. Oh, I think it's like this. And then say case push. And do that. So we can use our switch here. So I guess what we want to do first is verify that there is another token. If index plus 1 is less than the length of tokens, if it's not, that's when we have the problem, isn't it? Then we don't know the line number anymore. So nothing to push. Nothing to push. So then we go tokens, index plus 1. Or actually, you know what? Go index plus equals 1. Like that. So we go to the next token, which should be a number. Right? So we try to parse it. And then we say invalid int. If we fail to parse it, and then we append. So that's our push. Push done. Add, we want to go case add. Make up do that since we have such big text. Stack too short. That's pretty much it, You don't need to change anything there. There's no extra operations. So sub is the same thing. Stack too short. Done add and sub, so we'll get rid of those. And then there's our jump, if equal to 0. This is the one we need to change, actually. It's a bit complicated. So let's do our read and print first. Let's do read and print first. To read, we're reading from standard in, so I think there's nothing to change here. Just say invalid int, and then print. So this is where we are printing a token. So just like we did with push, we need to move to the next token, make sure it exists, nothing to print if it does not. And if it does, we don't need to do this substring malarkey. Message not provided. We just need to say, now that we've incremented, we just need to say tokens index. So that's our print. Case halt is return, and the default case is unknown token. Boom. Whew. Okay. So we can clear out these ones that we took care of. And I think the only thing left is the loop. Okay. Something tells me that halt should be at the bottom. So let's put our loop above it. I don't know that we can really reuse this code. It says that it wants to pop something off the stack. Stack too short. It does, doesn't it? Okay, so all right, let's take this code. It is actually kind of useful. Because to jump if we're equal to 0, first we need to grab something off the stack. We say the stack's too short if we can't do that. And then we compare that to 0. And if it is 0, then we jump. And this is the part we need to change. So this is where we go. This is where basically we loop through all the tokens. Again, we're going to need to have a regular for loop. So let's say jump index. Jump to label is not a thing. Get rid of that. And we are going to have an error message if we reach the end of that loop. But it's more like label not found. Well, label not provided also. We also need to do that. So first we need to see, like, can we pop something? And then I guess we should also straight off say, I feel like that it doesn't really matter, but nothing to jump to. Let's say nothing to jump to, and here we say label not found. So now we want to say if the token at jump index, actually want to take a slice of it with negative what? Can I do that? Can I do that? Let's just try. I think this is something that I saw in, is it Python? Cannot slice token jump index of type U8. Tokens jump index. Cannot be negative value. Okay. So we can't do that. So let's just go jump token. So what I was trying to do, I've seen it in Python before, where you say -1, and that means 1 before the end. So it would have just lopped off the last character, which is what I'm trying to do. So what I'm trying to do is, so I've come across jump equals 0. First we see, is there something to jump to? So we check whether we've got another token available. Then we check if we've got something on the stack, because we also need something on the stack. Then we pop from the stack, and let's also go jump label equals tokens. Let's grab the jump label. So that's what we want to jump to. So now we just need to find somewhere, like for example, here we want to jump to L1. So we want to find this token, L1 colon. So we want to match them together, but one is just L1 and the other one's L1 colon. So we need to find an L1 colon. So we either need to put a colon on the end of our L1. Actually, that's probably more efficient than taking a colon off everything else. So let's do that actually. Let's do that. So we'll just go jump label equals a slice of jump label with len jump label -1. So that should cut the end off. Maybe there's a better way to do it, but that will do. Now, if we've, so if tokens jump index equals our jump label, then that's where we need to jump to. Do we want to jump to that or the one after it? Well, let's assume that some idiot put it right at the end. Then this condition will return false and just nothing would happen and we're at the end of the program. Okay, so that doesn't matter. So we can do +1 so that it goes straight to here. Instead of going to here and then saying, oh, it's just a label, skip it, and then going here. Okay, so what we need to do is say index equals jump index +1 and break out of the loop because there's nothing more to do. So actually this is just going to break out of this loop and then go to this error. And I put this error here with the idea that if we go through here and we don't find anything, then it will fall down to here. And that's not going to work because we're just breaking out of here anyway, so we're still going to here. But Odin also has labels, at least for for loops. I don't know if you can put a label anywhere else. But if we go to interpret, put interpret loop there, then we can go break interpret. I think that's it. And then it should jump back all the way out. Should jump all the way to the top here and then continue down as normal. Okay, so I think that's our jump if equals 0. And there's one more thing we need to do. I think it's in here. We want to say if, damn it, if token, we want the last character of the token. I think there's a strings.has suffix, oops, suffix. We're going to do that, and then we can say colon. So I don't need to do that? Okay. Then continue. That's fine. We just found a label, nothing to do. If we didn't find a label, then we found something that we don't like. We found a token that we don't like. Okay. So I think that's going to work. We don't have the greater than. Let's see what happens. Stack too short. Stack too short. And we don't have our line numbers anymore. I wish we had put the effort in. Do we want to put the effort in now? It's a bit complicated. bit complicated. So instead, maybe we can just print as we go. So we can just go we'll just put the name of the command here like this. Just some simple debugging, because I can't get the debugger to work. So, okay. So we did push, push, add, jump if equal. And then we found a label, which already sounds wrong, actually. And then we pushed and subbed. Because we didn't jump. We didn't jump. So we found the loop label, then we pushed, then we subbed. So when we do add, we do push. We do append. So we push one on, push a second one on, take both of them off, but put another one on, then jump. Does jump? I popped, but I don't think that was necessary. So I think when we're going to jump, we just look at the last one. We just peek the last one. We don't actually pop it off. Yeah? So then that got us further. So then we pushed, we subbed, we checked if we were equal to 0, which we weren't, and then we got an unknown token because we haven't implemented jump greater than 0. And because we already have, geez, it's a decent sized function, isn't it? This is what you should not do. Do as I say, not as I do. And that's how it goes. So I just change this, and then I say if a is greater than 0. Probably don't even need to do that too. We can just directly check the stack. Boom. Jump greater than 0. Label not found. Could not find the loop label. This is the first time, because both of these jumps didn't happen. This is the first time we're actually jumping. So good old print line debugging. So let's do a jump check. With 2 strings. The first string is the jump label, and the second string is what we found. We took it off. We took off the last character of this when we should have added the colon. That doesn't help, does it? Strings.concat colon. concat innate. Oh, that's right. It's an array Did I use it anywhere else? I didn't actually. Okay. So I think I should be able to take that out actually. Let's see. Nope, label not found. So let's see, with that label not found, but where's my print lines? I'm starting at 0 while it's less than the length of tokens. Increment, print. Oh, because I copy pasted. This is why you don't copy paste, kids. This is why you don't copy paste. So that last one looks like I found it, but then we don't see any more executions of stuff, and we just end. Because I'm telling it to break out of that loop. That's not what I want. That's not what I want. I wanted it to break out of the switch. Can I break out of the switch? Huh, maybe. Unknown token. Unknown token 2. Should it not be jump index +1? Because this is the label. So it's saying, is the token. So then I was saying, well, go to the token after that, which should be push. But it found 2. Okay. I think it might be in an infinite loop. I mean, I guess it's a big number, so it's going to have to print out a lot of stuff. Okay, let's take away this. Let's take away this debugging because it's going to slow things down a lot, I think. So if I just say like 2 and 1, so that should happen really quickly. let's review this. So definitely we're getting down to here, and it's jumping. Oh, it's because I went index plus 1 and got the jump label. No, I still don't understand why I do this instead of plus 1, but anyway. Let's get rid of this because I don't know if that's doing what I intended it to do. And I also think that we need a jump function because, yeah, it's not working, is it? It's too much. It's getting too confused. So this is the jump function. We're passing tokens, which is a pointer to an array of strings. The index, which is an int. Actually, let's do this. Let's say jump label let's say label token. We do want to look at the tokens. Fuck it, let's leave it. Do this the old-fashioned way. Jumped as false, jumped as true. If not jumped, it's because the label was not found. Copy and goddamn paste. Yeah, it's still looping forever, seems like. So, holy shit. We've been going for an hour and a half already. Okay, let's just see if we can get this program running. We're almost there. Just this annoying loop. Once this loop is resolved, we'll be sorted. We'll be away laughing. So it does seem like it goes down to the loop. It pushes 2 and then does a sub, so it should subtract 2. This is where that order really matters, doesn't it? when I was checking equal or even, equal or not equal on the previous one, the subtraction order didn't matter, because to check if they were even, we just subtract one from the other, and if we got a 0, they're even. But that doesn't matter which one you subtract from the other. So if we push 2, then we get 2 here. And we get, so this is going to be 3. Push 2, subtract 2, so it's going to be 1. Not equal to 0, greater than 0. So we loop 2, we sub, and we get -1. It's probably going to wrap around, give us, because it's unsigned. So I wonder if what he did was in his subtraction, maybe he said, you know, if your subtraction goes below 0, just clamp to 0. I'm quite curious, so I'm going to have a quick look in his interpreter. Stack, halt, pop, add, sub. No, just B minus A. He pops A, then he pops B. And he says B minus A. So that's the top of the stack. He's subtracting the top of the stack. This is the top of the stack. And I'm subtracting the top of the stack, yeah. Okay, so I'm doing the same as him, but I'm sure it's going to go to negative. Maybe the languages that we're dealing with have different ways of handling it. So can I just go like that? Yeah, see, look at that. It's a giant number. Okay. And of course, max doesn't work because the subtraction yields a giant number. So let's say if B is greater than A, just use 0. Otherwise, so we can't go below 0. That's what it was. So we had 3, because we pushed 2, then 1, we added them together, we get 3. It's not 0. We come down here, that's just a label. We push 2, then we subtract 2 from 3, we get 1, doesn't equal 0, is greater than 0, so we go back up, push 2, and then we say one minus 2, which would be -1. And then we fall down to odd, because none of these trigger. No, wait. What? If we subtract 2 and we have 0, it's odd? I'm questioning this logic. I mean, we got the right result, but I have a feeling that if we add 2 here, it's still going to say odd. Yeah. I am questioning this logic. So if we have 4, it's not 0, then we push 2, so 2 is on the top of the stack, so it becomes B. That's 2, that's 4. 2 is not greater than 4. So we say 4 minus 2 is 2. Which makes us loop again. Then we get 2 minus 2 is 0. So then we go here. That doesn't make any sense. I'm also going to go back here and just look at what kind of, I mean, it's Python. I don't know if, so his stack, what is it? SP, is that a stack pointer? I don't think we need a stack pointer. He's setting up a buffer and a stack. Okay, he's done it a bit more of a complicated way. Equals number, there's no type information here. So it probably is signed, actually. We said at the start, we're not going to do signed. Well, where are signed? Let's do I64. Replace all. And in our subtraction, we want to make it, yeah, we made it simple again. So that's saying odd. If I put 5 there, it's probably going to say even. Yeah, because the sub went to -1, which is not right. It should be like that. If you're continuously subtracting 2, you're eventually going to get to 0 or -1. If you get to 0, it was even. So you jump here and say even. Okay. That's it, ladies and gentlemen. I think that has been enough. Sorry, there just is one niggly little thing, now that I've said that, that I thought I had fixed. So if we go, this is what we called it before, message. And then we slice that message. We're just going to take off the quotes. Odd. And then we're going to read. We're going to say 5 odd. 2 even. 68 even. 47 odd. Okay. I'm satisfied. Whew, what a mission. And it turned out to be confusion of signed and unsigned, but I'm quite happy with what we got. Would have been nice to get line numbers in our error messages. That turned out to bite us in the ass. But we have 2 programs down, 1 to go. Then our interpreter is finished, and we move on to a compiler. Awesome. All right, cheerio.